Let's look at how to evaluate and solve using our given functions. So here we're given f of x equals negative x squared minus 6x plus 4 and g of x equals 3x plus 1. The first thing that we're asked to do is to evaluate f of negative 3. So when we're evaluating a function, this value that's being given to us is an x value or an input, and we're asked to find the output value that goes with it. So in our function f, everywhere we see an x, our input variable, we're going to replace it with a negative 3. So we end up with the opposite of negative 3 squared minus 6 times negative 3 plus 4. Be careful as you're simplifying here. If it helps, you can imagine kind of an invisible negative 1 with that negative that's out in front. So we're going to do our exponent first and then multiply by that negative or the negative 1 out in front. So negative 3 squared, negative 3 times negative 3 is positive 9. So we really have negative 1 times 9 minus 6 times negative 3 plus 4. So now multiplying, we have negative 9 plus 18 plus 4. So negative 9 plus 18, we have 9 plus 4, which gives us 13. So what this is telling us is that if the input is negative 3, the y, or the output, is going to be a positive 13. So on that one, our instruction word was to evaluate. Let's look at one where our instruction word is to solve instead. So we're still looking here at our function f, but this time we're given a value that we want f of x equal to 4. So this 4 is our output value, or our y. So when we need to solve, what we're going to do is we're going to take our given function and we're going to set it equal to our given value of 4, and we want to solve for the input variable x. So I can start by subtracting 4 from both sides of my equation, which cancels out our constant term here. So we're left with negative x squared minus 6x is equal to 0. So thinking about ways that we can solve this, I'm going to factor out a common factor on the left-hand side. So notice that both of our terms here have the variable x. They're also both negative, so I'm going to go ahead and factor out a negative x from each one of those terms. So from the first one, a negative x squared, if you take the negative and an x, it leaves behind a factor of x. From the second one, negative 6x, if I take the negative, it's going to leave behind a positive 6, and still our factor of x is out in front. So you can always check by multiplying. Negative x times x is negative x squared. Negative x times 6 gives us that negative 6x. And then just set each factor equal to 0 to solve for x. So here we get that x equals 0. Here subtracting, we get that x equals negative 6. So this is telling us that if x is equal to 0 or x is equal to negative 6, then our function will have an output of 4. Or another way to say that is that f of 0 is equal to 4, and also f of negative 6 is equal to 4. So if we were to plug those values in and evaluate as our input of 0 or negative 6, then our output would be 4. Let's look at our other function, g, here. So in addition to evaluating for integer value inputs or fractional number inputs, we can also input algebraic expressions. And so this expression inside of the parentheses here is still our input for this function. So in our function g, where we see the x, we want to remove that x and instead replace it with 2x plus 3. So this is going to become 3 times 2x plus 3 plus 1. So it gives us 6x plus 9 plus 1. So we're just distributing here with our 3. And then combining our constant terms, we have 6x plus 10. So since our input was a variable expression, our output is also a variable expression in this case as well. So a function gives us back the same type of information that we put in. Let's look at one more here. So still thinking about our function g, we're back to our instruction word of solve. So solve means that we know the output, we're looking for the input. So I'm going to take my function g, my 3x plus 1, and set it equal to 17. So subtracting 1 from both sides, we have that 3x equals 16, so x is equal to 16/3. Just leave it exact as a fraction rather than doing a decimal approximation. So the input in our function g that will give us an output of 17 is an input of positive 16/3.